In this video, we will talk about the methodologies of trigonometric substitution. I have to let you know that in this video, we will do the methods only. So there is no example in this video. So for the example for each of the three cases of trigonometric substitution, you have to watch the following videos. Before we talk about trigonometric substitution, one thing that I have to review is right triangle trigonometry. So in simply speaking, people just call that SOHCAHTOA. So what is SOHCAHTOA? Let's start on the right triangle I prepare for you. So I have a right triangle. This is a right triangle because one of the angle is 90 degrees. The theta is an angle measurement. On the opposite side of the theta, we have the opposite side. Okay, that is how they came up with this name opposite. That is on the opposite side of the theta. Right next to the theta, we have adjacent, and then the other side is called hypotenuse. So SOHCAHTOA, starting with the SOH. So SOH means sine of theta is equals to opposite divided by hypotenuse. O and H, so SOH. And then CAH is cosine theta equals to adjacent divided by hypotenuse. And then the TOA, TOA is tangent theta equals to opposite divided by adjacent. And then the pink on the right hand side is the reciprocal of the blue. So for example, the cosecant is the reciprocal of sine. So cosecant is equals to hypotenuse divided by adjacent. Reciprocal means you have to swap the numerator and the denominator. Secant is the reciprocal of cosine, so secant is equals to hypotenuse divided by adjacent, and cotangent is the opposite of tangent. Cotangent is equals to adjacent divided by opposite. In trigonometric substitution, there are three cases. So the case one, in the integrand, you will see that there is a square root or radical. Inside the radical, we have a constant square minus x squared. A is equals to a constant. So the first thing that you will have to do is you have to let x equals to a times sine of theta. So x is equals to a times sine of theta. So you have to do a substitution first. And then the next step is you will have to use this identity. 1 minus sine squared is equals to cosine squared. This is based on the basic trigonometric identity. Sine square theta plus cosine square theta is equals to 1, right? So cosine square theta is equals to 1 minus sine square theta. And then the domain of the theta you see, that is designed for definite integral. I know that doesn't make too much sense right now, but when we get to an indefinite integral or definite integral, you will see how this works. So let's take a look at case 2. Case 2 is inside the radical, the radicand, you have a constant square plus x squared. So case 1 is a minus, case 2 is a plus. So in case 2, you have to let x equals to the constant value times the tangent, and then the identity is 1 plus tangent square equals to secant square. For definite integral, you have to let the theta be between negative pi over 2 and positive pi over 2. So in case 3, this time we have an x squared minus a squared. So x squared minus a squared. So first in the substitution part, you have to let x equals to a times secant theta, and then the identity is secant square theta minus 1 equals to tangent square theta. This identity is for you to do some rewrite in the integrand, because the given integral, when you do a trigonometric substitution, so the given integral, it doesn't matter which case you encounter, every time you get an integral and then you have to do trigonometric substitution, most likely, like 99.9% of the time, there is no sine, cosine, tangent in the integrand. They will just give you a dx, and then you will see x in the integrand. So the first step is you have to do a substitution. So you have to let x equals to a times tangent theta, secant theta, sine theta, whatever that is. So the purpose of doing the substitution part is we want to change the variable. Change from what to what? Change from x to theta. All right. So now, after the substitution is done, the integrand is in terms of theta, right? And then you have to do some rewrite. So for example, in case 3, you have secant square theta minus 1 equals to tangent square theta. So after the rewrite, you might be able to do some cancellation, and then after the cancellation is done, you can integrate. So after the integration part is complete, the answer is in theta, but the given integral is in x. To go from theta back to x, you will have to use the right triangle trigonometry. So that's how the trigonometric substitution works. So sometimes when you work on definite integral, you will have to let the theta between a number and another number. So that's how trigonometric substitution works. All right, so that is the end of this video. In the following video, I will give you example for each cases. So I will see you all in the next video.